All right, this is AP BC Calculus. We're doing Unit 9, Section 4. This is a BC only topic. So we are defining and differentiating vector-valued functions, which I will probably call VVF sometimes because it's easier. So let's go ahead and get started. So a quick review of vectors and vector notations. So vectors have both a magnitude, meaning a size, and a direction. So that's different than a scalar, right? So when you're asked, the opposite of a vector is generally considered to be a scalar. So for instance, velocity is a vector because it has both a magnitude and a direction. You can have a -10 velocity because the negative indicates the direction, whereas a speed would be a magnitude only, so that's called a scalar, right? So you can have 10 as a speed, but you can have -10 as a speed. There's no direction. So there are two common notations for vectors. Both are ways to display the components, horizontal and vertical, if we're in 2 dimensions. But if you were in 3D, like if you were dealing with real-world applications in 3 dimensions, then there would also be an in and out dimension for z, right? So pointy brackets, right, which are sort of, they look like this, right? And they have the x direction and then the y direction, right? So the x direction meaning horizontal and the y direction meaning vertical. So as you see here, vector v could be written as 3 comma -4 because it is 3 units to the right and then down 4 units, right? So that's vector v. Horizontal component is a +3, vertical component is a -4. Or you can use what's called ij notation. So the unit vector, a vector a single unit long in the horizontal direction, is called I in the positive direction. So again, a vector that looks like this, right? 1 unit, just 1 unit in the positive x direction would be vector I, and 1 unit in the positive vertical direction, so a single unit long would be vector j. So you can write vectors as multiples of those unit vectors in the vertical and horizontal direction. So this vector could be written as 3i, because that would be 3, 1, 2, 3 of the I vector, and then -4j because it's 4 units down. Okay, so that's what we mean by that. Vectors are generally written in lowercase letters. In books or typed sources, vectors are usually in bold, right? But when you're handwriting them, they usually put the little vector arrow on top of it because bolding things by hand is just generally awful. You'd just be sitting there like writing a darker and darker V, and that would be weird when you could just do a V with an arrow, right? Okay, so vector-valued functions are functions that are defined parametrically. Basically, this isn't different than what we've been doing since 9.1. It's just we're talking about a slightly different way of looking at it. So for instance, f of t could be written as x of t, meaning the x direction motion, or the x direction position, or whatever, comma y of t, which would be the vertical position or velocity or whatever this function represents. You could also write that as x of t and then the I vector, because that means in the x direction, and y of t times the j vector, because that means in the y direction. When you differentiate a vector-valued function, basically it's super intuitive. You just differentiate the pieces, right? The same is true if you're doing anti-differentiation. If you're integrating, you would just follow, basically do it piece by piece. So if we have f of t as this vector-valued function, right, the first derivative, f prime of t, is just going to be x prime of t comma y prime of t, still in pointy brackets, or x prime of t in the I vector direction horizontally, and y prime of t in the j vector direction, which is vertically. If you want to do the second derivative, it's the same thing. You just differentiate again, right? Your f double prime of t would be x double prime of t in the x direction and y double prime of t in the y direction, or you could write it in ij notation, and that's basically it. It's actually one of the more intuitive things that we're going to do in BC Calc. It really builds pretty seamlessly on the stuff that you learned in early AB Calc with differentiation, and on the stuff that you learned in the middle of AB Calc with anti-differentiation or integration. So let's go ahead and walk through it. We're given a vector-valued function. So we have x direction and y direction. We're asked to find f prime of t and then f prime of 1. So f prime of t is just going to, and I'm going to suggest that you just stick with the notation that you're given. If they use pointy brackets, use pointy brackets. If they use ij, stick with ij. I personally prefer the pointy bracket notation, but it doesn't really matter. So if I differentiate this thing, because this is my x, right? So if this is x of t, I'm going to get 3 minus 10t. And if I differentiate the y component, right, I'm going to get a 3t squared plus a 16t. And that's it. X direction, y direction, that's it. And then f prime of 1 is just going to be what happens when I plug a 1 in. So 3 minus 10 should give me a -7, and 3 plus 16 should give me a 19. So there's my f prime of 1. And that's it. go ahead and give the same thing a try, right? You're given a g, find g prime of t and g prime of 2. So g prime of t should be a 12t plus 5, comma, a negative 4t cubed plus 7. And again, I think this is one of the more intuitive things that we're going to do in these later BC Calc sections. So g prime of 2 just means plug a 2 in. So that'll be a 24 plus 5, which is a 29. And this will be a negative 4 times 8. So it's a negative 32 plus a 7, which should be a negative 25. And that's it. All right, so this is a little bit more complicated, but not a whole lot more complicated. So we're finding the second derivative, so that means we have to go through the first derivative. So the first derivative is going to be the derivative sine of stuff, which is cosine of stuff. So I'm going to get a cosine of 2t times the derivative of the 2t because of the chain rule. So I'm going to get 2 cosine 2t. Same thing with the e to the stuff. The derivative of e to the stuff is e to the stuff, but then I need to include the derivative of the stuff, right? So it's going to be a negative 3 times e to the negative 3t. To find f double prime, I just differentiate again. So the derivative of cosine of stuff is going to be negative sine, but then I remember I have to multiply by that 2 for the chain rule. So I'm going to get negative 4 sine of 2t, right? The derivative of this e to the stuff is going to be e to the stuff, but then I have to multiply by the negative 3 because of the chain rule. So I'm going to get a 9e to the negative 3t, and that's my answer. Same thing, you're going to go ahead and do that with g. We're finding g double prime. So g prime of t is going to use, now you could FOIL this out, right? But it's a bad idea, right? This is a bad idea to FOIL slash distribute, right? You should just use the chain rule, right? This would be a really big thing to expand, and it's much easier with just using the chain rule. So when I differentiate, I'm going to get, this is 4, this stuff, sorry, missed a t. 4 times this 3t plus 1 to the third times the derivative of the 3t plus 1, comma, the derivative of the cosine 6t is going to be a negative sine 6t times the 6. So negative 6 sine 6t. Now I'm going to clean this up a little bit and recognize that that's actually a 12 times a 3t plus 1 quantity cubed. The 12 cannot be moved inside, and none of that stuff can be moved outside, right? And that means that my g double prime of t, when I differentiate this again, right, I'm going to get that this is a 36 times 3t plus 1 quantity squared times the derivative of the inside, which is another 3. And here, the derivative of a sine is a regular cosine, but I'm going to have to multiply by 6. So this will be a negative 36 cosine of 6t, right? And then I'm going to clean up this last little bit. That should be 108, right, because it's a 90 and an 18. So 108 times this 3t plus 1 quantity squared, comma, negative 36 cosine of 6t. And that's my g double prime, right? And that's the answer we want. Now, you don't have to necessarily show that step in the middle that requires work. I know you can do that in your head, but I'm showing it here just to make sure we know. All right, so let's go ahead and find this. Now, this is one I can check on the calculator, right? I'm finding h prime of 2, not the equation for h double or h prime, just h prime of 2. So I can find this on a calculator if I want. Excuse me. So I am going to do it by hand, but then we'll double check our work on a calculator. So this is going to be a product rule, and this is also going to be a product rule. So first I'm going to find h prime of t, right? I'm going to get u dv plus v du, right? And then when I do the other one, the other product rule, I'm going to get u dv is going to be a negative e to the negative t, right, because of the chain rule, right? Plus v, which is e to the negative t, du is just going to be a 3. Now, there's not really a huge incentive for me to clean this up because I'm asked to find h prime of 2, not h prime of t. So I'm going to get that this is a 4e squared plus another 4e squared, right, because that would be 2 times 2. And then for my y component, I seem to get a negative 6e to the negative 2 plus a 3e to the negative 2. So if I clean that up, I seem to get that this should be an 8e squared and a negative 3e to the negative second. Cool, so that's what I should get, right? So that's my answer for h prime of 2. Now, we can check this. So if we're asked to check this, right, to check on a calculator, you can either be in parametric mode or you cannot be in parametric mode, to be perfectly honest. It's okay if you want to be in parametric mode. It's also okay if you don't want to be. So if I'm in parametric mode, I could call x1t the t squared e to the t, right? And I could call y1t the 3t e to the negative t. Let me double check that that's correct. 3et, okay. So if I did that, let's go ahead and go to my y equals, and let's see what happens if I do that. So I can do t squared e to the t, right? And I can do 3t e to the negative t. And we'll double check that those are right. Now, what I can do, there are two options, right? What I actually want to find, right? So I can find this one of two ways, right? I can either go to n derive, right? So I can go to n derive. I can do x1t with respect to t at 2 and get an approximate value, and then I can type in this value and see it's the same, right? And I could do the same thing here. I could do n derive, which is math 8, and y1t with respect to t at 2 and see if it's the same. But that would be fine, right? So that's one option. So go math 8 vars over to y vars. You pick parametric, and I want x1t, comma, with respect to t at 2, right? And I get that this is a 59.112. Right? And then I could check. I could say, hey, what's 8e to the second? And there you have it, right? So that's great. So check, that works, okay? So that's right. And I could do the same thing. I could hit second enter, and then I'm just going to overtype the x1t with a y1t, right? So vars over to y vars. I want parametric, and I want 2. And I get that this is a negative 0.406, right? And then I can check that, right? I can see what negative 3 e to the negative 2 is and see if my answer comes out right. And sure enough, it does. So answers are right. The other way to do this, right? So, or the other way to do this is you can use second and calc, because if you remember that there were some derivatives in there. So if I do second and calc, see how I can pick, I could pick dy dt. So this would be number, for dx dt would be number 4, right, which would be dx dt. And if I wanted to pick dy dt, I'd pick number 3, which is dy dt, right? So let's go ahead and pick 4 for a sec. And then what I can do is I can type the t value I want and hit enter, and there you go, there you have it, right? So if I do that, and I'll go ahead and take a quick screenshot just to put that on there. So, oh, my bad. Just to put that on there so that we can see that that's what happens, right? And you could do the same thing where you go to second calc, right? And you pick 3, right? And then I can hit the x value that I want or the t value I want. It's the same answer. So there we have it, right? So you can check it either of those ways. It's possible that you'd be asked this skill on a calculator section, but probably not on a question that was easy enough to be done by hand, but you could definitely be asked this question. So let's go ahead and do a P3. You're going to do this one by hand again, but totally check it on a calculator. You can and should, because that way you're building the calculator skills you need. So K prime of T, right? This is another product rule, U and V, and this is a product rule, U and V. So I'm going to get that the X prime is going to be U dV, which is cosine, right, plus V, which is sine, and then du, which is e to the t, comma. And then here I'm going to get U. dV is going to be a negative sine, right, plus V, which is cosine t. And then this is going to be a negative e to the negative t, right, because of that chain rule. And then I kind of ran out of room, but you get the gist. Okay. So that means that my K prime of 0 should be e to the 0 times a 1. And actually, you can probably be a little lazy about that. You can jump right into saying that you know e to the 0 is 1, right? So e to the 0 is a 1, cosine of 0 is a 1, sine of 0 is a 0, so it doesn't really matter what else happens. This is an e to the 0 again, so it's a 1 times a 0 plus a 0 times a negative 1, right? So it seems to me that when I clean all of this up, I get an answer that is just 1 and negative 1, right? So that's pretty straightforward. So it shouldn't be super hard to check those in a calculator. If I want to check them, right, I'm going to go ahead and put my x1t in as the e to the t sine of t. I'm going to put my y1t in as the e to the negative t cosine of t, right? And then I can go ahead and differentiate. So let's go here. I want an e, right? So second natural log to the t, sine of t, right? Sine of t. And then I want e to the negative t, cosine of t. And there we have it. So quit out of that. And honestly, I can just hit second enter a couple times. So I can find the y one right away, right? I'm just changing that to 0. And sure enough, this is a negative 0.999 repeating. or negative 1.00 if I round. So that checks out. That's the right answer, right? Because remember, this is approximate, right? This is approximate, and this is your actual work. So your calculator doesn't actually differentiate at a point. Your calculator does a very high-level approximation. And then I can go ahead and hit enter again, and this time I'm just going to change this to the x variable. So I'm going to go to var over to yvars pick var over to yvars pick parametric and pick x1t, and there you have it. This is a 1.000, right? These two are approximate, and so that checks out. Those are the same answers. All right. So let's do another non-calculator one. I'm really with E4 and P4 and E5 and P5. I'm pretty sure, well, sorry, E4 and P4. I'm just checking that you understand the IJ notation, right? So H prime of T, I is a notation that indicates the direction. It's not a product, right? This is the function you're differentiating. So when I differentiate cosine of 2t, I'm going to get negative 2 sine of 2t. And then the I is just the vector direction. Like this is the function. The I is just the direction. And when I differentiate the t squared plus 1, I'm going to get a 2t. And the j is just the direction. Excuse me. All right, so that's my first derivative. My second derivative, again, I'm just going to differentiate those functions. The I and j are not a product. They indicate the direction. So when I differentiate again, derivative of sine of something is just cosine of that thing, but I have to multiply by 2 for the chain rule, so I'm going to get a negative 4 cosine of 2t. And again, the I is just the direction. And then I'm going to get a 2, and then the j is just the direction. Okay? Go ahead and give that a try with k, and find k prime and k double prime. So k prime of t, right? I'm going to differentiate the functions, right? The I and the j are just directions. So the derivative of e to the 3t is going to be 3e to the 3t because of the chain rule, right? And then the I is the direction. The derivative of 4t squared plus 3t is going to be an 8t plus 3, and then the j for the direction. My k double prime of t is going to be a 9e to the 3t, right? Because I differentiate again and have to multiply by that 3 for the chain rule. And then this is just going to be an 8. And the j and the I are just the direction. Last example and last practice problem. Again, non-calculator, but you can check this with a calculator. We're going to find the slope of the line tangent. Remember, that means dy dx, which in parametrics, sorry, it's been a long day, means y prime of t over x prime of t, right? So I'm going to do the same thing I've been doing, right? This is my x, right? This is my y. I'm going to find x prime, I'm going to find y prime, and I'm going to evaluate them at 2. So x prime of t, and actually you can just go ahead and write this as f prime of t if you want, right? So your x prime of t is going to be a negative 3e to the negative 3t, and your y prime is going to be a 2e to the 2t because of those chain rules, right? So the tangent slope should be, evaluated t is 2, should be this 2e to the 2 times 2 over a negative 3e to the negative 3 times 2, right? So that's a 2e to the 4th over a negative 3e to the negative 6th, which is a negative 2/3 e to the 10th, right? That's all we want was the slope. You can check this in a calculator, because in the calculator, if you put these in, so if you put in, so when we go to check it, right? If you want to go check it in our calculator, which you should do so you learn these skills, you can put your x1t in as the e to the negative 3t, and you can put your y1t in as the e to the 2t, and then there's actually an option for dy dx, right? So if I go to second calc and I pick dy dx, right, I can find that value. So let's go ahead and put in that this is a second natural log. So that's an e to the negative 3t. And this one, if we clear it, is a second e to the 2t. Cool. And then we'll quit out of there for a sec. And if I go to second trace, I can pick dy dx. And then I want at the moment when t is 2. So I get that this value is approximately a negative 14684.3, blah, 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 right? But that's close enough, because what I'm going to do is I'm going to go ahead and quit out, and I'm going to type in negative 2 divided by 3 times an e to the 10th and see what happens. And there you have it, right? So that is that. Check, we're good. All right. So go ahead and give this one a try. Again, try it without a calculator. We're going to find the slope of the tangent line to f of t at t is negative 1. Right, so And again, if I wanted to communicate a little more clearly, actually here, I might have gone out of my way to say something like this was x prime of 2, or sorry, y prime of 2, and this was x prime of 2, but that's even a little bit iffy because these were never actually labeled as x and y, so this is probably just fine. You do want to show that communication that that's what's happening though, right? Communicating understanding is what's going to get you credit on an AP. So my f prime of t is going to be a 3t squared, comma, 14t, right? And that's it. So my tangent slope is going to be the 14 times the negative 1 over the 3 times the negative 1 squared. So I'm going to get a negative 14 over a positive 3, and that's it. When I go to check, right, I would put in my x1t as a t cubed plus 1. I'd put in a y1t as a 7t squared minus 6, right? So let's go ahead and go back and do that. So we're going to do t to the third plus 1, and we're going to do a 7t squared minus 6. I think that was right. Let's double check real quick. Yep, okay. And then I quit out of there, and I can go ahead and hit second trace, and that's how I get calc, and I want dy dx, and I want it at the moment when we plug in, I believe, negative 1. So we hit enter, and I get, so I did second calc, and I picked dy dx, right? And I got that it was approximately a 4.666 blah, 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 right? And then if you want to double check, you can check that you get 14 divided by 3. Should give you that 4.6, but I want to double check because I don't think I got a negative. Negative 1. Oh, I did. My bad. Sorry. I missed the negative. All right, cool. We're good. All right. And that's it for this video.